Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Mr. Fayaz Ahmed Kuche from Baramallah. I'm being posted at Ashpura Higher Secondary, Kupara. Today, I may discuss about demultiplexer. 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 I have written here demultiplexer. I may tell you that demultiplexer is the reverse of multiplexer. In multiplexer, we were discussing one to many or many to one. Sorry, we are discussing as multiplexer. We are writing multiplexer. We were writing many to one. But here demultiplexer means one to many. What does this mean? This means that one is your input and many is your output. Okay, this is one. You have one input and many outputs. Here you are having many inputs and one output in multiplex, but in demultiplexer you have one input and many outputs. So let me draw the block diagram for this demultiplexer. One input, many outputs. This is the block diagram for 1:4 demultiplexer. 1:4 demultiplexer. Demultiplexer. Okay. It has got two selection lines, S1 and S0. It has got two selection lines, S1 and S0. We are discussing about demultiplexer, which has got one input and many outputs. So this time I am discussing about 1:4 demultiplexer. It means one input and many outputs. That means four outputs, one input and four outputs. So when you have two selection lines, we are writing S1, S0. When two selecting lines, these are acting as inputs, selecting lines for this input. So we are taking it up to 4, 0, 0, 1, 1. Here 0, 1, 0, 1. You have got four outputs, Y0, Y1, Y2, Y3. You will write here Y0, Y1, Y2, Y3. These are four outputs and two input signals, selecting lines, one input. Suppose this is D input. So what you will do, when you are giving selecting line 0, 0, this is activated. This is D, rest are 0. When you are giving 0, 1, this is activated D, rest are 0. When you are giving 1, 0, that means 2, this is activated and rest are 0. When you are giving 1, 1, that means 3 is activated and the rest are 0. In this way you will get the output of this demultiplexer when the two signals activate. When you are giving 0, 0, for example, you are giving 0, 0 signals, input signals, activating D input, you will have Y0 will get activated. Similarly, when you use 0 and 1 in input signals, you will have Y1 getting activated. Similarly, the rest of the outputs will get activated with the input signals as I have shown here. So with this I may tell you its min terms, how will make its min terms, these min terms of all this. You will have 0 0, that means S1 bar, S0 bar, D plus, so plus you will have, sorry, not plus, S1 bar, S0 bar for this with this D input. Similarly, you have here, that is for Y0. Now again Y1 will be equal to, Y1 will be equal, this one will be equal to S1 bar S0D. Y2 will be equal to, Y2 will be equal to S1 S0 bar D. Y3 will be equal to Y3 will be equal to S1 S0 D. So you may have followed, when we are giving, when taking min terms for it, when you have got this D, Y0 will get activated on the input signal 0 and 0. You have got its min terms like this, S1 bar, S0 bar for this. Similarly here, S1 bar, S0, S1 and S0 bar. Again here, S1, S0, D. You will have this as min terms. Now we have to draw this was its block diagram. This was block diagram. 1:4, one is demultiplexer, 1:4 type. This is demultiplexer 1:4 type. So you may draw the logical diagram for it. Its logical diagram is like this. You will have two signals, S1, S0, S1's NOT gate here, which will act as S1 0. Similarly here, NOT gate, which will act as this S1, this S0. So this is now S1 NOT, this is S0 NOT from here. So you have got third input as D, as here D input. You have got four AND gates. Four AND gates here. 1, 2, 3, and 4. 4. So first one is S1 bar. S1 bar is from here. S1 bar from here connected to here. Then you have got S0 bar. S0 bar is here. Similarly, you have D connected to every wire. D connected everywhere like this. This will be Y0. Similarly, in second form, Second term, you have S1 bar. S1 bar, that's here. S1 bar. Then S0, positive, S0. And D. D is connected everywhere. This will be Y1. Similarly here, the third term, you have S1, positive. S1, S0 bar. S0 bar is here. And third term, D. D is connected everywhere. This is Y3. Similarly here, S1, S0. S1 is positive. Here, S0 is 2 positive. And D. This is was Y1, Y2. And this is Y3. So that is your logical diagram for 1:4 demultiplexer. So dear students, you may watch it keenly. It's only the reverse of multiplexer, demultiplexer, called as demultiplexer. So I'm sure that you may have understood its logical diagram, block diagram. Logical diagram is to take the simple form given here. So that will do for today. Okay, so